Good day everyone. Today is another series in Cash Mathematics for SS3, and in this particular video today we are going to be dealing with geometry and vectors. Now this video is going to be a quite lengthy one, so though it's not going to be very long, but I implore you to try to at least finish the video, watch it to the end so that you can gain as much as possible, because I'll be giving you a lot. Now let's start from angles. An angle is a measure of rotation or turning. So now 1 revolution is equal to 360 degrees and 1 degree is equal to 60 minutes. The names of angles change with their size. Now in this figure you have that of an acute angle, which is between 0 degree and 90 degree. Now for this acute angle, it is between 0 and 90 degree, whereas a right angle is exactly 90 degree. And also a straight line, angle on a straight line is exactly 180 degree. Then an obtuse angle is an angle that is between 90 degree and 180 degree. The next we also have the reflex angle. Now reflex angles are between 180 degree and 360 degree. So the angles are formed when lines meet or intersect. Remember the following facts. Now there are different facts that you can sum up the properties of angles, and the first of those facts is that the angles at a point add up to 360. So what that means is that anytime you have a point and you have different lines meeting together at that point, now the angle between all those lines, when you add those angles, they must give you 360 degrees. So in this case you can see that A plus B plus C plus D plus E, they all give 360 degrees. Another rule of angles is that adjacent angles on a straight line add up to 180 degrees. So in this figure you can see that B plus A, or rather A plus B, whichever you want, equals 180. Next we have vertically opposite angles are equal. So what this means is that when two lines cross, the angles in between those crossings are equal. So in this case this is an X angle. Now you can see that P equals Q and R equals S. Those are vertically opposite angles. Now these theorems, they will hold through. They are always true in mathematics. So no matter where you go, no matter what you solve, these theorems, they are like universal truth in mathematics. Next we have alternate angles are equal. So in this diagram you can see that you have 4 angles, X, M, N and Y. So in this case an alternate angle is also known as a Z angle. So because it involves angles that are inside and outside the meeting point of the Z lines. So in this case that means angle X will be equal to angle Y. So this, when you trace the lines, they form a Z alphabet. And then also we have angle M is equal to angle N. So it also forms an inverted Z angle. You can also call it an S angle if you like. Then lastly we also have corresponding angles are equal. So what this means is that angle A equals angle B and angle P equals angle Q in this last diagram. Aside this, there's also another theorem that states that interior opposite angles add up to 180 degrees. So this is another theorem that you should also know, but the diagram is not included here, but it exists. Now let's move on to an example, the first example for this video. So in this example we're asked to find the angles marked A, B and C in the figure. So in this diagram we have a line, we have the 5 different lines meeting, and then some of these lines are parallel to each other. But as you can see in this angle A is one of the angle formed when two lines meet at a point. Now at this point we know that the sum of angles is 360. So that means when we subtract 360, when we subtract the other angles from 360, we'll get the angle A. So in this case A will be equal to 360 minus the other angles, which are 230 degree, 213 degree and 28 degree. Now A will be equal to 360 minus 241, that is 119 degree. So moving on to the next part, we have B, angle B. Now in this case angle B is an interior angle, because I said earlier that interior angles sum up to 180. So that means the sum of angle A and angle B will give you 180, because they are the interior of lines. So now that means B will be equal to 180 minus A. So B is 61 degree. Then next we have C. So C also, we have C, and C will be equal to B. The reason for that is that C and B, they are alternate angles. You can see that they are like Z angles. Now in this case, C will be equal to B and to also be 61 degree. Now let's go on to triangles. Now angles in a triangle. The sum of the angles in a triangle is two right angles or 180 degrees. In figure 19.10, angle A plus angle B plus angle C is 180 degrees. So that's the first theorem, and that's one of the most basic theorems you will ever come across that involves triangles. The next theorem involving triangles, which is less common but also important, is that the exterior angle of a triangle is equal to the sum of the two interior opposite angles. So what this means is that when you have a triangle like this, the exterior angle will be equal to the sum of the opposite interior angles, which it doesn't have on the line. So that means M is equal to P plus Q in this case. So aside that, we also have types of triangles. Then let's talk about those. We have the names and the properties of triangles. Now we have 5 different types of triangles here. We have the scaling triangle, and the scaling triangle is a type of triangle that has all its sides unequal. The next we have the right angle triangle. A right angle triangle is a triangle that has one of its angles as a right angle, which is 90 degrees. Now the side facing that right angle, notably, is called the hypotenuse. Now this hypotenuse is the longest side of the triangle of a right angle triangle. Next, we have the obtuse angle triangle. So it has one of its angle as an obtuse angle, which is greater than 90 degree but less than 180 degree. Then fourth, we have your isosceles triangle, and it has two adjacent sides equal, and one pair of base angles equal. So and then finally we have the equilateral triangle, and this equilateral triangle, as its name implies, has all its sides equal, and coincidentally it also has all its angles equal. So it's also an equiangular triangle. Similar to that on triangles, let's solve an example, the second example for this video, where we'll be talking about what we've done so far. Now in this example, we're asked to find the angle P. Now in this example, you can testify that angle P will be equal to angle Q, because these are base angles of an isosceles triangle, which will be equal. That means P plus Q will be equals to the exterior angle, and that is because the exterior angle is equals to the opposite interior angle. So the converse is also true. The opposite interior angles are equal to the exterior angle. That means P plus Q equals 126 degrees. But in this case, P is equals to Q. So that means P plus P equals 126. That means 2P equals 126 degrees. And then finally, when we divide both sides by 2, we have angle P as 63 degrees. So very simple. Now let's move on to congruency. Now in triangles, there is a condition called congruency, and there are different um, conditions satisfying this. So congruent means the same in all respects. So when your settings are equivalent, it's also the geometric equivalent of congruency. Two triangles are congruent if number one, two sides and an included angle of one are respectively equal to two sides and an included angle of the other. So the abbreviation for this is SAS. So you have a side, an angle, and another side. So now, or if two angles and a side of one are respectively equal to two angles and a side of the other. So the abbreviation for this is ASA or AAS. So note here that the side, side that is given could be in between the angles or not, but it's still another condition for congruency of triangles. Now moving on, we also have a third condition for congruency, and that is when you have three sides of one are respectively equal to three sides of the other, and this is abbreviated as SSS. Or finally, we also have when they are right angled and have the hypotenuse and an order of one equal to the hypotenuse on the side of the other. So this is RHS. So that means they must be both right angled, and the hypotenuse and another side of one must be equal to the hypotenuse of and side of the corresponding order. Then next, folks, let's solve an example on this theorem so far. Now we have given figure 19.14. Name the triangle that is congruent to triangle XYZ, keeping the letters in the correct order. So what this means is that you are looking for a triangle that is congruent to the triangle XYZ. So the triangle XYZ, you can see it in this diagram. Now we have triangle XYZ is equivalent to triangle ZWX. So because the side angle and side are corresponding. So the reason for this is that look at this angle. The reason for this is that angle line XY equals line ZW. So XY equals ZW. The reason is that it has been given to be equal in the diagram. They give us equal. Then next we also have angle YXZ equals angle WZY. And the reason for this is that these are alternate angles. So because YX is parallel to ZW. Then finally we also have line XZ is equals to line ZX. So XZ equals ZX. So because they are common sides. So these are the reasons. That is why triangle ZWX is congruent to triangle XYZ. I would say au revoir to triangles. Let's say welcome to polygons. Now, a polygon is any plane figure with straight sides. An irregular polygon has all its sides of equal length and all its angles of equal size. So polygons are named after the number of sides they have. So, for example, you can see the polygons. You have an equilateral triangle. An equilateral triangle is automatically a regular polygon with 3 sides. Now we have a square is a regular polygon with 4 sides. We have a regular pentagon. We have regular hexagon. So and just know that the word regular means all the sides are equal. Now in this part, these are the kind of things you draw in geometry with your compass, your pencil, and so on and so forth. Then I also promise that in the subsequent series I will be releasing such videos. Now next we are talking about angles of a polygon. There is another theorem in mathematics that says the sum of the interior angles of an n-sided polygon is n minus 2 times 180, or open bracket 2n minus 4 right angles. So the sum of the exterior angles of any polygon is 4 right angles of 360. Now always remember that a right angle is 90 degrees. Now this is the diagram below. So the sum of A plus B plus C and so on and so forth, no matter how many exterior angles, must be equal to 360. Next, let's solve a question on that theorem we just talked about. Now this question we are asked to calculate the interior angles of a regular pentagon. Now a pentagon has 5 sides and the 5 exterior angles add up to 360. Now the reason is that the exterior angles of any regular polygon, or rather any n-sided polygon, whether regular or not, must add up to 360 degrees. So since the pentagon is regular, the exterior angles are all equal. So that is another conclusion that we have arrived, and it is intuitive, it is natural, and it is axiomatic. Now next we have each exterior angles must be is equals to 360 degrees divided by 5, which is the number of exterior angles. So that would give 72 degrees for each. So that means each interior angle will be equals to 180 degree minus 72 degree. That's 180 degree. Now the reason why we are summing this is that the addition of the interior angle and the exterior angle will give us 180 because they are angles on a line. Now let's pause right there and continue on collaterals. Now collaterals are special types of polygons, and they have 4 sides as a unifying property of all of them. Now we have a trapezium. Now a trapezium is a collateral with only one pair of opposite sides parallel. So you can see it in this diagram. Then next we also have a parallelogram, is a collateral with both pair of opposite sides parallel. So you can see it below. In a parallelogram, the opposite sides are parallel, opposite sides are equal, opposite angles are equal, and then finally the diagonals bisect one another. These are the properties of a parallelogram. The next we also have a rhombus. Now a rhombus is a collateral with all 4 sides equal. So all the 4 sides are equal to one another. The next, in a rhombus, all the 4 sides are equal, and also the opposite sides are parallel, opposite angles are equal. Then we also have the diagonals bisect one another at right angles. Then finally, the diagonals bisect the angles. So these are the 5 properties of a rhombus. So moving on, Moving on, we also have other collaterals like a rectangle, which is a collateral in which every angle is a right angle. Now, in a rectangle, it's important to know that a rectangle has all the properties of a parallelogram. Then, in addition to all those, it also has all four angles, which are right angles. Then, it also has the diagonals, which are equal. Let's go on to square. A square is a rectangle that has all the four sides equal. In addition, all the properties of a rhombus are also properties of square. In addition to that, the square also has all four angles as right angles. It also has all the diagonals are equal length, and finally the diagonals they meet the side at 45-degree angle. So now let's move on to circles. Circles they are special, but they are because they have some special names attached to their parts. So let's give the names of the lines and the regions of a circle. And the line that bounds the entire circle is called the circumference. Then the a region bounded by a chord and an arc is called a segment. So you can see that that arc is also a portion of the circumference, and a chord is a line that joins any 2 points on the circumference together. Then a special type of chord which passes through the center of a circle is called a diameter, as you can see in this diagram. So it passes through the center of a circle, and then the line from the center of a circle to the circumference, any line, any such line is called a radius. And then that center of a circle is at the center of a circle directly. So that is where it's kind of like the focal point of the circle. So those are the different parts of the circle. And then finally we have the sector. So the sector is bounded by an arc and two radii. A circle has different theorems governing it, and one of those is that the line joining the center of a circle to the midpoint of a chord is perpendicular to the chord. I mentioned earlier that a chord is the line that joins the center of a circle. Sorry, rather that joins 2 points on the circumference. So this is the chord theorem of a circle. So and the converse is also true because anytime you construct a perpendicular at the midpoint of a chord and you trace it, it's going to cut the center of a circle. Now, secondly, we also have equal chords are equidistant from the center of a circle and vice versa. Then third, we have in equal circles, equal chords are equidistant from the center and vice versa. So these are theorems that hold for the circle, because one time you draw a chord that are equal in length, so anytime you construct the distance from those chords to the center, they will be the same. And also anytime you construct equal chord, they will always have the same distance from the center. Now next, we also have the angle properties of a circle. The angle that an arc of a circle subtends at the center of a circle is twice that which is subtends at any point on the remaining part of the circumference. So in this case, angle POQ is twice of angle PRQ. So if angle PRQ is x, then angle POQ will be twice of that. That will be 2x. Now, a special note here is that in these topics, I've dealt with them in a sufficient detail in previous videos in Crash Mathematics SS1 and SS2 and even SS3. So you can check out those videos in the corresponding playlist of this channel so that you can be able to grasp the theory of these circle theorems. So now here are other theorems involving a circle. The second is that the angle in a semicircle is a right angle. So you can see it in the diagram. So in that right angle, angle APB is at 90 degrees because it's subtended by a semicircle. Then the third we have is angles in the same segments of a circle are equal. So in this figure, angle APB will be equal to angle AQB, which will also be equal to angle ARB, and so on and so forth, depending on the number of angles. So the reason for this is that angle APB and angle AQB, they are in the same segment of a circle, and apart from that, they are subtended by the same chord AB. So each of them is subtended by chord AB, and they are on the same side of chord AB. So that is the reason for that. Next, we also have that the angles in opposite segments are supplementary. So anytime you say angles are supplementary, it means they add up to 180 degrees. So in this case, the opposite angles here, which are x plus y, will be equals to 180, and also p plus q must equals 180. So because ABCD is known as a cyclic quadrilateral, and a cyclic quadrilateral is a quadrilateral that has its four vertices touching the circumference of a circle. Hence, the opposite angles of a cyclic quadrilateral are supplementary, and it also follows that the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle, as you can see in this diagram. Next, let's talk about some theorems that are tied to the tangents of a circle. Now, a tangent is to a circle is a line which meets the circle at one point only. So the first theorem that is tied to a tangent of a circle is that a tangent is perpendicular to the radius at the point of contact. That means this tangent ATB will be perpendicular to the radius OT. So where T is the point of contact. Now, secondly, we also have the tangents to a circle from an external point are equal to a length. So in this diagram, we have when you have a tangent drawn to this circle from an external point T. Now those tangents A and B, they must be equal in length, and also there are also other conclusions from this. For example, TA will be equal to TB, and also angle ATO must be equal to angle BTO. That is another conclusion from this. Finally, we also have that angle AOT will be equal to angle BOT. Yeah, that's also another conclusion from this, and OT will be equal to OT. So it also bisects the angle, bisects AB at right angles. So this is the line AB. So those are the conclusions from this the fact that they have an exterior tangent. Then next we have the angle between a tangent to a circle and a chord through the point of contact is equal to the angle in the alternate segment. So in this figure we have angle TAB will be equal to angle ACB, and angle PAC will be equal to angle ABC. Now in this case, the reason is that when you have a chord, now the angle between the chord and the tangent must be equal to the angle in the alternate segment, or the segment that is opposite the segment that contains the tangent. Now let's get off circles and let's move on to triangles. Here we are talking about similar triangles which have the same shape but may be of different size. Now if the three angles of one triangle are respectively equal to the three angles of another, then the two triangles are similar. Now there's a difference between similarity and congruency. Now in congruency, their size and angles must be equal. So when two triangles are congruent, they have the same angles and have the same length of the sides. But in similar triangles, it's only their angles that are equal and their length of sides are not necessarily equal. Then next in this case we have in similar triangles, what is important is the similarity ratio. So in the corresponding sides and in the proportion AB over DE must be equals to BC over EF and must be equals to CA over FD. Now let's take an example to side. Now we are given this triangle and we asked to calculate the length YZ and length ZB. Now in this case, in the first triangle XYZ and XBA, you can see that angle XZY will be equal to angle XAB. So because this is given, XYZ equals XAB. So it's been given because they've been marked with the same symbols. Then following this, we also have angle X will be equal to angle X. They are common. So angle XYZ is equal to angle XBA because that's the third of triangle. XYZ equals XBA. That's the third of triangles. So because if two angles of a triangle are equal, that means that follows that the third angle, the third corresponding angles will be equal correspondingly. Now next we have hence triangles XYZ and triangle XBA are equiangular and similar. So that is the theorem. YZ over BA equals XZ over XA is equals XY over XB. So that's because these triangles XYZ and triangles XBA are similar. So that means YZ over BA, which is 8, equals 10 over 12 equals 9 over XB. Now let's pick the ratios which we need, which are that YZ over 8 equals 10 over 12. When we solve that, we'll get YZ equals 6 over 2 over 3 as answer. Then next, when we take the next ratio, when we solve that, we have 0.8. ZB is 0.8. So you can see that we've applied similar triangles to solve something that normally we wouldn't have been able to solve without similar triangles. Now I want us to note that similar triangles are named with their corresponding letters in the correct order. So it is advisable to write down all three parts of the ratio, whether or not they are all required for the answer. So you have to follow the correct order when it involves similar triangles. Now let's talk about intercept theorem. So that means if three or more parallel lines cut off equal intercepts on a transversal, then they cut off equal intercepts on any other transversal. So I'll show the diagram now. Now this is the intercept theorem. You can see three parallel lines, and then they are cut by these transversals. So now these three parallel lines, they are represented by these three arrows going from left to right. Then these transversals, they are just random lines that cut through the parallel lines. So what this theorem is trying to say is that since AB equals BC, so because of the fact that they cut off equal intercepts, so this intercept AB will equals to BC. That means XY will equals XZ. That means these three lines, they will cut off the same equal intercept on any other transversal. So these three parallel lines, they are the one cutting the intercepts, and they cut the intercepts AB and BC, which are equal. That means they will cut off intercepts XY and YZ, which will also be equal. Now we can take the ratios, that AB over XY equals BC over YZ. So that is also true. Also, a line drawn through two sides of a triangle parallel to the third side divide the two sides in the same ratio. So that means this line which divides run through the two sides, AB will divide the containing side in the same ratio. That means XA over AY will be equal to XB over BZ. Next, let's talk about the midpoint theorem, which states that the line joining the midpoint of two sides of a triangle is parallel to the third side and equal to half of it. So this midpoint theorem states that anytime you have a line joining the two midpoints of the two sides, it will be parallel to the third and also equal to half of it. So in this case, MN is parallel to BC and MN is half of BC. So that the midpoint theorem is a special case of one of the intercept theorems. And next, let's talk about the angle bisector theorem. But before we talk about that, I encourage you to watch this video to the end, and I hope you are enjoying this video. Please don't forget to like, share, and subscribe. So the angle bisector theorem states that the bisector of an angle in a triangle divides the opposite side in the ratio of the sides containing the angle. So in this diagram, you can see that AB over AC, which are the two containing sides, is equal to the ratio of the value of the opposite side. That's BX over XC. So this is one theorem. It's very useful. Now let's treat an example to demonstrate that principle. And this example is by given that CB is parallel to ED and BX is the bisector of angle ABC. Now you are asked to use the given information to calculate side AX and XC. So from here we know that AC over CE equals AB over BD. And the reason for that is that the bisector theorem. So next we have AC over 7.5 is equals to 6 over 9. Next we have so basically AC over CE, that's AC over CE. Now in this case that will be equals to AB over BD. Now that is part of the theorems of when you have a parallel line to one side, so it will divide the other two sides in the same ratio. Next, when we solve for AC, we'll get 5 centimeter. Then next, let's use the AB over BD. AB over AD equals ABC over DE. That's because this triangle ABC is similar to triangle ADE. So when we solve that, we'll have BC is equals to 4 centimeter. Then next, when we use that, we use that knowledge to solve AB over BC equals AX over XE. So the reason for this is the bisector theorem. So when you bisect an angle, it divides the containing sides in the same ratio as the opposite side. So next, when we solve that, we'll also have XC as 2 centimeter. So these theorems, they are all connected. We have used 3 theorems to solve one question. Now let's move away from polygons and the likes, and let's go on to vectors. So Vectors, if you've done introductory physics classes, you would have known that vectors have magnitude and direction. A vector is represented by directed line segments, and the magnitude of the vector is the length of the line segment. Now we can see the vector OR in this figure. So this is a Cartesian plane, and then we're using a Cartesian plane because a Cartesian plane is the best way to represent magnitude and direction of vectors. Not that you cannot use other ways, but it's kind of one of the most ideal way. Now, a displacement from O to R is equivalent to a movement of 2 units to the right and 3 units up. So it's just like we are making use of Cartesian coordinates. And OR is represented by a Coulomb vector, which can be represented as 2, 3. Now, this Coulomb vector, it's used to represent the vector, and the magnitude of, or the modulus of the vector is the square root of the sum of the squares of each of these coordinates. So that's 2 and 3. So you look for the square root of the sum of the squares of 2 and 3. That's square root of 2 square plus 3 square. That will be the square root of 13. So that is vectors. Let's talk about something very important that involves vectors. I mentioned earlier that vectors have magnitude and directions, right? Now, what we've talked about, we'll talk about the magnitude, but now if we dwell on the direction, when we reverse the order of the arrow, which instead of going from O to R, even we are going opposite, if we are going from R to O, then our vector will become RO, and to be the negative or inverse of vector OR. So this is one thing that many people begin to grapple with when it comes to understanding vectors, because it is kind of like the distinguishing factor between vectors and scalars. But you need to understand that when you reverse the order, you've reversed the vector and it has become a negative vector. So and its Coulomb vector is now negative of 2, 3. Hence, RO is equals to minus OR. So anytime you reverse the direction of the vector, you are basically changing the sign of that vector. Always remember that. So now let's talk about equal and parallel vectors. So two or more vectors are equal and parallel if they have the same magnitude and directions. So in this case, you can see that vector AB and CD, they are both parallel. That is the reason why we say parallel, is that they are moving in the same direction. So and also the length of these vectors, they are equal. So that is why they are equal and parallel. Now folks, let's go on to position vectors. So a position vector is basically a localized vector. So what does that mean? A position vector is a vector that has its position already specified. So the position vector of P is relative to a fixed point O. Anytime you specify the position of the vector relative to any axis, is called a localized vector. So and then now we are no longer talking about the vector in absolute terms. We are not talking about it in relative to its displacement from a fixed point O. So that is what position vectors are. And these position vectors, they are used in very many real life situations, in relative motion, in a lot of things. So position vectors, most of the time when we are performing calculation of vectors, we make use of position vectors because they give us a relative background where to kind of hinge our calculations from. Then next, let's talk about the sum of two vectors. Vectors can be added together using the law of vector addition. So what this means is that when you add the vectors together, you have to add both their magnitude and their directions. So that means your resultant vector will also have a new magnitude and a new direction. So as you can see in this diagram here, we have vector OQ and vector PR. So when you add them together, you can get the vector and a new vector with this, that's QR. Now you can see that this new vector has its own different magnitude and direction. So that is the addition of vector, and don't mistake it for sum of scalars. That's different from sum of scalars. Now let's talk about a continuation of vector addition, and we have the law of vector addition. When you add vectors, it's just like as if you are adding the columns. So you can see that PQ plus QR is equals to column vector 2, 1 plus column vector 1, 3. So when you add them, that will give you column vector 3, 4, as in that PR. So now this PR, when we add PQ plus QR, as in the previous example, we'll get vector PR. That is an example of vector addition. Now if R and P are the same position, then PR is 0. Where 0 is 0, 0 or null vector. A zero vector has zero magnitude and its direction is not defined. More than two vectors can be added together by applying the law of vector addition. So as you can see in this diagram, we have myriads of vectors technically speaking, but they are just 4 or 5 vectors. Now when we are looking for PR, vector PR, you can see that is equals to the sum of vector PQ and vector QR. So vector PQ, which is U, plus vector QR, which is V. That means vector PR will be U plus V. Then next we also have vector PS, which is the sum of vector PR plus RS. So that is vector that U plus V plus W, and so on and so forth. So you keep adding. Vector addition has to do with adding the magnitude and directions, as you can see. So now the last time we talked about the sum of two vectors, right? Now this time around, let's talk about the difference between two vectors. And after this, there's only one thing left for us to do before we call this video off. Now, to subtract a vector u from a vector v, add the negative of u to v. So in this case, what we're trying to say is that anytime you are subtracting a vector u from a vector v, all you need to do is you just add the negative of that vector to the um, first vector. So v minus u, vector v minus vector u is the same thing as the sum of vector u, vector v plus the negative of vector u. So as you can see, I'll give an example now which talks about that. Now we have PQR is a triangle and D is the midpoint of QR. Show that PQ plus PR is equal to 2PD. Now we are trying to show something in this example. Now we are given that PQR is a triangle and D is the midpoint of QR. Now we want to show that PQ, which is this one, PQ plus PR is equal to 2 is twice of vector PD. Now from this diagram, let me solve it. Continuing from where we stopped, so vector PQ is equals to PD plus DQ, as you can see in the diagram. So PQ is equals to PD plus DQ. So that's the addition of vector law. Then also we have PR equals PD plus DR. So next, when we add them together, we have PQ plus PR equals to PD plus DQ plus PD plus DR. That will be 2PD plus DQ minus RD. That will be 2PD plus DQ minus DQ. That will be equals to 2PD. Now the reason why RD is equals to DQ is because D is the midpoint of QR. So that means RD and DQ will be the same things, because anytime you have vectors, these vectors, they are literally parallel, but the only difference is that they are in opposite directions. So that means when you add them together, you will get 0 as an answer. So that's the solution of this question. Finally, let's talk about another concept, which is the Cartesian component of a vector. Now this is all about the fact that you can talk about the vectors based on their Cartesian component. So we have the vectors ON and NP are the Cartesian components of the vectors OP. So OP will be equals to ON plus NP, because ON and NP is equals to Cartesian components of OP. Now let me note here that the vector is equal to the sum of its Cartesian components. Now moving on, we have that the position vector of the point P relative to O, the origin, is xy. So OP is equals to ON plus NP, that's xy. The magnitude of OP is given by the root of the sum of the squares of its components. So the direction of OP is the angle theta, which is mixed with the horizontal axis. So theta is equals to the tan inverse of y over x. So that is one thing you should know about the components of vectors. Now, I'll give a solution, a question which deals with the Cartesian component. So now we have given that R1 equals 1 minus 3 and R2 equals 4 minus 5. Express R1 in the form m theta, where m is the magnitude and theta is the acute angle it makes with the horizontal axis. Then next, we have to find the vector R2 minus R1 and calculate its modulus. Now, let's solve this. Solving this, we have R1 as 1 comma minus 3. And as such, we have the magnitude of R1 as root 10. Then also we have, let's theta be the angle between R1 and x-axis. So when we do that, we have this theta as 1 minus 3 over 1, which is minus 3, because theta is in the fourth quadrant. So we have theta as the tan inverse of minus 3, that's minus 71.6 degrees. So R1, we've expressed it in the form of the plus comma the angle. Now that is the form we asked. Then R2, In the second question, we're asked to look for R2 minus R1. So when we evaluate that, that's 3 minus 2 column vector. And then when we look for the modulus of that resultant vector, that's the square root of the sum of the square of 3 and minus 2. So that's root 13. So that is all for this question, and at the same time all for this video. So thank you for watching up to this extent, and I hope you've gained a few things, one or two things from this video. And you can also comment on this in the video, and don't forget to like, share and subscribe. Thank you.